Okay, so in this video, we're going to have a look at how computers store images using just binary numbers, just ones and zeros. So the first thing we have to do is split our image up into small areas of colour. And these we call pixels. So a pixel is the smallest element of an image, and each pixel is just one colour. So in this case, each pixel is either black or white. And using that, I can draw a smiley face. There we go. It's not a very good smiley face, but it's a smiley face. And then to write this down using binary numbers, all we need to do is write down a 0 if we don't colour it in. So the whole top row is just zeros. And write down a 1 if we do colour it in. So using that method, we can then have a binary pattern, binary code that represents our image. And I could give that binary pattern to somebody else and they could recreate that image by just not colouring in the zeros and colouring in the ones. So that's the simplest way we can store any picture using binary numbers. So if you have any picture that's black and white, no matter how big it is, you just write down a 0 for every uncoloured in block, each uncoloured pixel, and a 1 for each coloured in pixel, and you end up with the binary code that you can save to your computer, send as an email, or whatever you like, and that's how images are stored in computers. Now, it does get a bit more difficult once you start introducing colour, because at the moment, our colours are either white, not coloured in, or black, coloured in, and most pictures have a lot more than two colours. So how do we solve this problem when we have a lot more colours? So here I've got a picture that has a few more colours in. So this picture has some blues, some yellows and some greens. It's not a very clear picture, but it's supposed to be some grass, sky and a bit of sun up in the top corner. So how can we represent this using just ones and zeros? Because we can't say yellow is 0 and blue is 1. That wouldn't work because then we've got nothing for green. Well, what we do over here is we make a little key, and my greens are going to be 0, 0. For blue I'm going to use 0, 1, and for yellow I'm going to use 1, 0. And then we do exactly the same as last time. We go through each pixel one at a time and write down its colour using the binary code. So 0, 1 for blue, and there's 3 of those, and then 2 yellows which are 1, 0. Next row is the same, blue, 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 yellow, yellow, and then 5 lots of blue on the next row. Next row is green is 0, 0, so it's just going to be one big line of zeros down here, and then the same again for the very bottom row. So what we have here is another binary pattern, another binary code that we can save to a file, send as an email, or however we want to store this, and then anybody else, any computer system, as long as it knows what the key is, can then recreate that image exactly as it was when we got it. And that's how binary images work. Now this 2 bits per pixel has a very special name, and that is colour depth. So the colour depth of my image is 2 bits per pixel. That means for each pixel I'm using 2 binary digits, or for each 2 binary digits I've got 1 pixel. And that will give us potentially 4 colours, because there are 4 possible combinations. So I could perhaps add some red to my image, or it looks more orange there, but it is a red pen. So I could add a 4th colour to my image without having to increase the colour depth. And that's fine. But what if we wanted more colours than that? Because most images do use more than 4 colours. Well, it might not be a huge surprise to know that much like everything else with binary numbers, we just keep doubling. So if we have 1 bit per pixel, so colour depth of 1, apologies for the lack of a space, it is 2 words, so colour depth of 1, possible number of colours is 2, because we have 1 or 0. Yep, 2 possible colours. If we have a colour depth of 2, then we can have 0, 0, 0, 1, 1, 0 or 1, 1. So we can have 4 colours. Colour depth of 3, we can have 8 numbers. because we could have each of these with a 0 in front, or we could have each of these with a 1 in front. So we have potentially 8 numbers. Colour depth of 4, we double again to 16. Colour depth of 5 would give us 32, and so on. We just keep doubling. So however big our colour depth is, we say 2 times 2 times 2 times 2 times 2, and we just keep doubling to find out how many colours we could possibly have. And what you'll find actually is that most computer systems these days have either 24 or 32-bit colour, which is a lot of bits per pixel, and gives us some quite large image files, but also some really high quality image files. So that's pretty good. So what else is there when we're storing images? Well, you'll remember, and we'll see if it's still on this board, that originally we had this grid of zeros and ones. So the colour depth here is just 1 bit per pixel, and we also have the resolution, and the resolution can also be described as the pixel dimensions, because this image is 5 pixels wide by 5 pixels tall, giving us a total of, skipping to the answer there, 25 pixels. So if we have 25 pixels, 5 by 5, that tells us how big our image is. And more likely you'll hear numbers like, for example, on your computer, if you want to set a wallpaper, it might well be 1920 pixels wide by 1080 pixels high. And I won't bother doing the maths, but it's about 2 million pixels on your typical computer desktop wallpaper image, which is a lot more than my 5 by 5 grid. So the two main factors that you need to look at when you're considering the image quality and the image file size are the colour depth, which is how many bits per pixel. Is it 1, or is it 2, or is it 3? And the pixel dimensions or the resolution. Okay, now in computers, when we're talking about displaying things on monitors and things like that, the resolution is the pixel dimensions. It's how many pixels wide, how many pixels high. If you do some other courses like iMedia, or you're interested in printing, then you might have a different definition for resolution, because that gets confusingly used for different purposes in different circumstances. But certainly for GCSE Computer Science, resolution is how many pixels wide by how many pixels tall an image is, and is used to help you work out whether your picture is going to be really high quality or really low quality, and also whether it's going to be a really big file because you have to store all those pixels, or a really small file because there aren't many pixels to store after all.